it's our second lecture related to EST Physics past papers solution. In this lecture, we will continue our chapter number 2. We are covering the MCQs which are repeated in past EST Physics papers. So by doing these problems, you can do a 90% of your paper. Perfect. Okay, so now today's lecture we have to start our chapter number 2, important MCQs, which are the topic related to dynamics. We will cover Newton laws of motions. You know that the first law of motion, the second and the third. The first law of motion is basically describes the law of inertia. An object remains at rest or moves at the straight line at the constant speed unless there is no external force applied to it. Okay, and in second law of motion basically tells us about the law of acceleration. The acceleration of an object is directly proportional to the net force and inversely proportional, okay, to its mass. F equals to ma. This is the Newton's second law. And our Newton third law, second law of motion is this. And Newton third law of motion, you know, that tells us about the action and reaction. For every action there is an equal but opposite reaction. Okay, now move on towards our uh, MCQs types. So the MCQs is which of the following statement is correct definition of the Newton first law of motion. Newton first law of motion, we know that basically first of all tells us about the law of inertia. So to if a body remains in motion, that remains in motion, and if a body is at rest, that remains in rest if no external net force applied on it. So the answer should be this. An object is at rest or move in the straight line at constant speed unless no external force applied to it. So this is the correct answer. Okay. Newton's second law of motion is represented by which of the equation? We know that the Newton's second law of motion is F equals to ma. According to Newton's third law of motion, if you push against a wall with a force of 10 Newton, the wall pushes you back with a force of exactly same. Okay, so the answer is 10 because for every action there is a reaction same in the opposite direction. Which of the following best describes the inertia? So inertia basically what is inertia? Inertia is basically the opposition in motion. Okay, opposition, or you can say the resistance in motion. So the answer is the resistance of an object to any change of its state of motion. So by doing a resist, your body change its motion from either rest to motion or motion to rest. So this is basically a resistance of an object to the change of its states of motion. If the mass of an object is double, what the applied force if and the applied force remains constant, the acceleration of the object will be half. How half? The correct answer is half because you know that F equals to ma. If F remains constant and if your mass is double means F equals to 2ma. Okay, so move this 2 to the other side. Okay, or if you are not moving to other side, so in other concept you can see because F is constant, F is not changing. F is a product of mass and acceleration. If mass is double, acceleration must be decreased by 2 factor, means half, to remain this force as constant. That's why if your mass is double, your acceleration is got halved. If your mass is increased by 4 times, your acceleration must be decreased by 4 times to remain the force because your force is constant. So the correct answer is be halved. Which law of motion explains why passenger moves forward in their seats when car suddenly stops? Because you know that when passengers are sitting inside a bus and driver suddenly pushes brake, so you can feel that the passengers moves forward. This is due to the Newton's first law of motion, because this is due to the inertia, because you are in rest. Once there is no brake, you are sitting on a seat of bus in rest position. But when your driver suddenly put a brake, your rest position changes into motion. That's why you go upward. Okay, so this is due to the Newton first law of motion. A 10 kg object is subjected to a net force of 50 Newton. Now the mass is 10 kg and the net force is 50. So what is the acceleration? You have to use Newton's second law of motion. F equals to ma. You have to find acceleration, so a becomes equals to f divided by m. So f is basically 50 divided by m, which is 10. So 50 divided by 10, and the answer is 5. The correct answer is 5 meter per second square. Which of the following scenarios is an example of Newton's third law of motion? Newton's third law of motion, we know that describes as to every action there is an reaction in opposite direction. So we feel that this is correct, because when a rocket is launched into space, uh, the upthrust it rocket is moving upward, and it leaves upthrust against the direction in opposite direction. So the correct answer is a rocket launching into the space is an example of Newton's third law of motion. The force required to accelerate a 2 kg object at 3 meter per second square is. Now the mass is 2 kg and the acceleration is this. Have to find force. F equals to ma. So 2 multiplied by 6, 2 multiplied by 3, the answer is 6 newtons. In the absence of external force, a moving object will. So in the absence of external force, if there is no external force, the moving object continuously move with the same velocity, means with a constant velocity, because there is no change in the velocity if no external force is applied, according to Newton's first law of motion. Okay, so the correct answer is this: continue moving at the same velocity. Now move on towards topics related to friction, tension, and normal forces. So what is basically the friction? First of all, you know that friction is basically the resistive force, the force between two objects, the resistive force, the oppositional force between the two objects that oppose the relative motion. It Friction basically opposes the motion. Okay, if a body is moving in motion, then it opposes the motion to comes to rest. Okay, and there are two types of friction: static friction and kinetic friction. Static friction is basically the friction that exists between stationary objects. If two objects are stationary and there is a friction between them, that is called as the static friction. And the other friction is the kinetic friction, the friction between the two objects that are moving. That we are walking on a road is basically an example of kinetic friction, and a car is standing on a road is stationary. Let's suppose car is not moving, car is stationary. So the friction between tires and road, if car is stationary, is an example of static friction, but when car is moving, the friction between the tires and the road is basically the kinetic friction. Okay, so when you push a book on table, friction opposes the motion of a book. Okay, tensional force. So what is tension force? So tension force, how you can define tension is basically pulling force. Okay, tension is basically the pulling force transmitted along a straight rope, cable, or similar object when it is pulled tight by force acting from opposite ends. So let's suppose a picture is hanging on a wall. So The tension applied on that string is called as the tension force on that string, or either it is rope or cable or anything else on which your object is hanging. Example, the force in a rope holding a suspended weight, like a painting on a wall, is suspended due by rope. Normal force, what is normal force? The normal force is basically the supported force exerted upon an object that is in contact with the another stable object. It acts perpendicular. Your normal force always acts perpendicular. Keep remember this thing to the surface of contact. Like you can say a book resting on a table experience an upward normal force. Like if there is a table and there is a book is lying on a table, so the normal force of is always upward of the book which is resting on a table. Okay, so let's do start the MCQs. These are the most repeated MCQs. Okay, in past EST physics papers we are covering these all MCQs, and if you provide this notes, this is total of 96 pages. This is the complete notes for EST physics preparation. These are all the past repeated MCQs of EST physics. If you require this note, just leave your comment below, or I will drop my contact number in the description below. You can contact, I will provide you in a normal fee. Okay. So the first MCQ is, which type of force act on an object that is not moving? Yes, we know that it's static friction. And when a car is parked on a hill, which type of friction prevent it from sliding down? Which type of friction? Yes, static friction, because car is parked, not moving. So the static friction between the tire and the road provides prevent that car to not drop down from hill. Okay. Tension in a rope is an example of which type of force? Normal force, applied force, pulling force, or gravitational force. So the answer is D, pulling force. As I mentioned you before, tension force is always a pulling force, not gravitational, not normal, not applied. The normal force of an object is always directed, yes, perpendicular to the surface. Which of the following statement about friction is true? Friction only occurs between solid? No. Friction can be both beneficial and detrimental. Friction always acts in the direction of motion. No, friction can be acts in the opposite direction of motion. Friction is independent of the surface. No, friction is dependent on the surface in contact. So the correct answer is friction has both beneficial and detrimental. Okay, detrimental. So what is the concept of this? Because you know that we are walking on road due to friction, so this is an advantage beneficial, and we are writing on paper due to friction. If there is no friction between paper and pen, we are not supposed to write on paper. Okay, so which force is responsible for resistance experienced when sliding a book across a table? So, which force is responsible for the resistance experienced when sliding a book across a table? So, there is not pulling, not normal. So, the frictional force between is responsible, okay, basically for the resistance experienced by sliding book on a table. So, if a block is hanging from a rope, okay, and let's suppose a block is hanging with a rope, and it is at rest. The tension in the rope is equals to what? Yes, the tension is always equals to the body weight. The body which is hanging, the tension must be equal to that weight. So the answer is A, the weight of the block, the tension must be equal to. What happens to the normal force if the angle of inclined plane is increased? If the angle of inclined plane increased, so the normal force always decrease. So keep remember this is a very conceptual problem. Okay, MCQs. You know that normal force is always directed perpendicular, but if the angle of an inclined plane is increased, your normal force should be decreased. Okay. Which type of friction is a typically greater for all the two surfaces? So the static friction is typically greater for the same two surfaces. Okay. Static friction is basically greater for the same two surfaces because when you are kinetic friction is when you are moving. So when you are moving, then this between two surfaces are not same and not greater. So the only friction which is greater for the two surfaces is the static friction. A box is being pulled across a rough surface. The force is required to keep the box moving at constant velocity is primarily upcoming which thing? Because your box is moving along a surface, then there is no tension, no normal force because moving though no static. So the answer is kinetic friction because your box is moving on a rough surface. So there is a friction between box and the surface, and that friction is called as the kinetic friction. Okay. Now next topic is about the circular motion. So what is circular motion? Circular motion refers to the movement of an object along the circumference of a circle. So if a body is moving in circle along a central point, this is known as the circular motion. And it for circular motion definitely it follows the circular path. It can be either uniform and with can be with a constant angular rate or rotation, and you can say the constant speed or non-uniform. So it depends your circular motion should be uniform, not uniform, a constant angular rate or constant speed. Okay. So in circular motion, the key points are we have to discuss about the centripetal force. We have to discuss about the centripetal acceleration. So whereas your centripetal force is concerned, what is centripetal force? Basically, this force is responsible to keep a body to move in a circle. Okay, to retain your body to always move in a circle. So the force is called as the centripetal force, the force that keeps an object moving in circular path, and centripetal force is always directed towards the circle center. Okay, center of the circle, and its formula is mv squared divided by r. Okay, centripetal force equals to mv squared divided by r. Example, the force that keeps a car on a curved road, because you know there is a concept of banking of road. If there is a curved road, the outer edge of the road is pushed up. Why pushed up? To keep the car move in a circle, okay, in about a center point of that curve. Okay. Well, now what is centrifugal force? Centrifugal force is basically the inverse of the centripetal force. The acceleration of an object move in a circle, it directed towards the center. Centrifugal force also directed towards the center of the circle. Basically, the acceleration of an object moving in circle. So centrifugal force is basically the acceleration of object that moves in a circle. Okay, and centripetal force is basically the force that keeps the body to move in a circle. And what is centripetal acceleration? This is not centrifugal, this is centripetal acceleration. And first of all, first is the centripetal force, the force that keeps the body to move in a circle. And centripetal acceleration, basically the acceleration that keeps the body to move in a circle. And the formula of centripetal acceleration is v squared divided by r. These two formulas are very important. Most of the problems came from these formulas. Example is the acceleration experienced by a rider on a merry-go-round, okay, rolling. So next concept in the concept of circular motion is angular velocity, which is denoted by omega. So the rate of change of an angle through which an object moves on a circle. So the angle. So in simple words, you can say the circular velocity of a body is called as the angular velocity. If a body is moving in circle, they must have the angular velocity, which is denoted by omega, and its formula is omega is equals to theta by t. Okay, and the example of this is a spinning wheel. Okay, now tangential velocity. What is tangential velocity? When a body is moving in a circle, there is always a tangential point which is normal to that point. Okay. The linear speed of something moving in a circular path. So if a body is moving in a circular motion having angular velocity and the linear speed of something that is moving in circular path is known as the tangential velocity, and its formula is v equals to r omega. Okay, what is tangential velocity? V equals to r omega. Very important formula. The speed of a point on an edge of a rolling disc is an example. So let's look head on the numericals, which are the past most repeated FDE, EST, Physics MCQs. Okay, which force is responsible for keeping an object move in a circular path? Yes, definitely is the centripetal force. The acceleration experienced by an object moving in a circular path, moving in a circle at constant speed, is directed. What? The acceleration experienced by an object moving in a circle is always directed. We know that the acceleration is always directed towards the center of that circle. If the radius of the circular path is double, while keeping the speed constant, the centripetal force, we know that the relation of centripetal force mv squared divided by r. So if the radius is double, so the centripetal force should be half because there is a factor of 2 in denominator comes. Because if radius is double, so it becomes mv squared divided by 2r. Means your centripetal force now becomes halved. An object moving in a circular path with constant speed experience. So if an object is moving in a circular path with constant speed experience, yes, centripetal force. Because moving in a circular path with any speed, you have to experience centripetal acceleration. Okay. If the speed of an object is uniform, circular motion is double. Okay, so what it says, if the speed of an object in a uniform circular motion is double, now the velocity is double, the centripetal force is, we know that the relation F is equals to mv square divided by r. So if the speed of an object is double, then what should happen? So now velocity becomes 2v because mv square, so v square means 4v square, means it becomes quadrillate, means 4 times. Okay, if the vertical circular motion, in a vertical circular motion, the tension in a string is maximum at, so when your string tension is maximum in vertical circular motion, so the bottom of the circle, okay, in the bottom of the circle, your tension in the string is maximum in the vertical circular motion. Vertical circular motion is this, moving like this up and down. Okay, if right and left, then this is horizontal circular motion, but if this is up and down, then means you can say top and bottom. Top and bottom circular motion is basically the vertical circular motion, and the tension is maximum at the bottom of the circle. Understood? The unit of angular velocity is, So what is the unit of angular velocity? We know that the velocity is a unit of meter per second, but angular velocity has a unit of radian per second. Okay. What happens to the centripetal acceleration if the speed of an object moved in circular path is tripled? Now, what happens to the centripetal action if the speed of a moving is of a circular path is tripled? Now, velocity becomes 3 times. So we know that the formula F equals to mv squared divided by r. So if v becomes 3v, so 3v square becomes 9v square. Means now your centripetal force increased by 9 times. So the answer is 9 times. Okay. Now let's move on towards our next topic, which is upon work, energy, and power. So what is basically work? Work is done when a force causes a displacement of an object. Okay, when a force applied to an object and it displaces some distance, this is called as the work. And your work must be measured in joules. Okay, you can say that it is the measure of the energy transfer that occurs when an object is moved over a distance by an external force. So if an external force is applied and it moves some distance or it covers some displacement, this is called as the work done. And your work done is always along the which component? Yes, you are right. Along the horizontal component. The work done along the vertical component is zero. Okay. So the formula is F dot D and the horizontal component is split, so it becomes F dot D cos of theta. Okay, and your work is made in joules. Now move on energy. What is energy? Energy is basically a capacity to do work. It should be kinetic energy and it should be potential energy, as well as there is another type of energy which is the thermal energy. Now what is kinetic energy? Basically the energy possessed by a body, by an object due to its motion. So the energy of an object due to its motion is called as the kinetic energy, and its relationship and its formula is kinetic energy equals to 1 by 2 mv square. What is potential energy? Basically, potential energy possessed by a body due to its position. Okay, and there is another type of energy which is the gravitational potential energy, and gravitational potential energy is always equal to mgh. This is the same. Potential energy is always due to position, and due to position there is always gravity, and the gravitational potential energy or the potential energy is equal to mgh, where g is the gravitational factor, gravity you can say. M is the mass and h is the height of an object which it covered. There is another concept of power. What is power? Power is basically the rate of doing work. The P is equals to W by T. So this is power. What is power? Power is basically the work is done or energy is transferred. Rate of doing work, you can say. Rate of doing work is so called as the power, or you can say energy transfer. And the formula of the power is P is equals to W by T. Okay. And the unit of power is watt, and 1 watt is equal to 1 joule per second. Joule is that is a unit of work, and 1 joule per second means if you have done 1 joule of work in 1 second, then this is equals to 1 watt. Okay, so power is equals to work done by time. Okay, rate of doing work. So relationship between work, energy, and power. So relationship between work, energy, and power. So work done is always equals to change in kinetic energy. So you can say work done is equals to final kinetic energy minus initial kinetic energy. And what the conservation of energy also it obeys, like kinetic energy initial plus potential energy initial always equals to kinetic energy final plus potential energy final. So here the conservation of energy obeyed. Okay. So example problems are if you want to find work done. So let's suppose a force of 10 Newton is applied so the now the force is mentioned, which is 10 Newton, is applied to push a box 5 meter. Displacement is given, which is 5 meter across the floor. The force applied in the direction of the displacement. Calculate the work done. You have to find. He are saying that the force is applied in the direction of displacement, means you are applying force in the direction of displacement, so the angle is now zero. And you know that the formula is f dot d cos theta when your angle is zero, because you are applying force in the direction of displacement, so cos of 0 becomes 1, and f dot d means 10 multiplied by 5, it becomes 50 joules. So the work is 50 joules. Okay. Now, how if you want to find the kinetic energy? So the sample problem is this. How you can find the kinetic energy? Let's suppose a car of mass 1000 kg. Now car mass is this and their speed is this. You have to find the kinetic energy. You know the formula of the kinetic energy. Kinetic energy is always equals to 1 by 2 mv square. M is this and V square you can easily find it is equal to uh, 200,000 joules. Okay. Problem related to power, how it comes. A machine does work of this and in this seconds. So calculate the work. You just have to divide your work divided by time. So 15,000 divided by 1500 divided by time, which is 10 seconds. You can got power, which is watts. So 150 watts. So these are how you the problem should came. Now move on towards our practice problems more. If you want to find work done, again a person lift 10 kg of weight. Now means mass is given, which is 10, and the displacement is 2. Calculate the work done. And the it also mentioned that calculate the work done against the gravity. Now because the work done is not only f dot d, it becomes because this is against the gravity. Now as I mentioned you before, your work done is also equals to the change in kinetic energy as well as the potential energy. So in that scenario, your work done becomes equals to potential energy, which is equals to mgh. So m is 10, g is 9.8, and h is the height, which is 2. So after calculating, you will get your answer, which is 196 joules. Okay. And the next is you have to calculate the potential energy. What if you have to find the potential energy? Potential energy, you know that the formula is mgh. Okay, so example is a rock of mass 5 kg. So the mass of rock is given and the height of the rock is also mentioned, which is 10 meters above the ground. You have to calculate the gravitational potential energy. So again you have to use mass 5, g 9.8, and height 10. Multiplying these three, you will get your potential energy, which is 490 joules. Okay. So what if you want to find to calculate the power? So let's take an example. An electric motor lifts an elevator of mass 1000 kg. Elevator has a mass of 1000 kg and height is 10 meters, and 20-second calculate the power. We know that power is basically the equals to work done per time, and work done is equals to f dot d. And F is basically the mentioned here. F is basically equals to MA. Okay, MA. So M is this. A is basically the 9.8, which is the gravitational factor. So multiplying 1000 by this 9.8, and you can also if multiply by this, so it becomes multiply by 10. So you can see here F equals to MA, as I told you. A is this 9.8 and F is equals to M, which is this, which is mass is this mentioned 1000. Okay, so this is after multiplying 1000 by 9.8, you will get the value of F. Okay, and we know that the power is basically equal to F dot D. So this is F, and you have to multiply it by D, means here is D, which is 10. So multiplying by 1000, multiply 9.8, multiply by 10, you get the up value of work. Okay, now your work value is 98,000 joules. 98,000 joules. Okay, because you have to find the power, you have to divide it by time, which is 20 seconds. So dividing by time, so you will get the power is which is this. Okay, sorry, your power is now this 4900 watts. Now move on towards MCQs on work, energy and power. These are the MCQs which came in the past papers of FDE EST Physics papers, which are very important. By doing these problems MCQs, you got 90% of your. Okay, we also cover pedagogy and English problems in our upcoming videos, so stay tuned with us. Let's start. So what is the work done by a force of 10 Newton? You have to find the work done. Force is mentioned 10 Newton, and displacement is also mentioned, which is 5. So multiplying your F, because your formula of work done is FW is equals to F dot D. So multiplying 10 multiplied by 5, you will get the answer, which is 50 joules. Okay, which of the following is a unit of power? We know that the watt is the unit of power. A ball of mass 0.5 kg is moving with a velocity of 10 meter per second. What is the kinetic energy? We know that the kinetic energy equals to 1 by 2 mv square, and putting the value of mass, which is 0.5, and putting the value of velocity, which is 10, you will get the value of kinetic energy, which is 0, which is 25 joules. Okay, the potential energy of an object at height h can be given by, we know that the relationship of the potential energy is equals to mgh. Okay, an electric bulb consumes 60 joules of energy in 1 second. What is the power? Power is basically division of work done divided by time. This is the work done, which is 60 joule divided by 1 seconds. So you can get again 60. So the power is 60 watts. Now move on towards our next topic, which is about the conservation of energy and momentum. So, what is conservation of energy? Conservation of energy basically means initial energy must be equals to the final energy, means there is no loss of energy. Okay, so we can define the conservation of energy as the total energy of an isolated system remains constant. Means that your total energy of an isolated system remains constant, means there is no loss of energy. Okay, isolated system remains constant. Over time, energy cannot be created nor being destroyed. This is a very important line. You already know that energy cannot be created by ourselves and cannot be destroyed by themselves only, but it can be transformed from one form to another. Okay, a pendulum swinging converts potential, and because when you see that pendulum move to its extreme position, then move its mean position. At extreme position its velocity is minimum, at extreme position its velocity is minimum, but at mean position it got the maximum velocity, because it changes velocity with respect to time. As it goes from highest point, its kinetic energy is low and its potential energy is max, and vice versa. So this is how conservation of energy is obeyed. But at mean position, the potential energy is zero and kinetic energy is maximum. But at extreme position, your potential energy is maximum and kinetic energy is zero. So this is how your conservation of energy obey. Okay. There is another concept of conservation of momentum. As conservation of energy is concerned, there is also a concept of conservation of momentum, means your total momentum remains constant, means your initial momentum must be equal to the final momentum. There is no loss in the momentum. Okay, if no external force act on it, momentum like energy cannot be created, cannot be destroyed. Similar to this, momentum also cannot be created, cannot be destroyed by ourselves. And the formula of the linear momentum is this: P is equals to mv. Okay, momentum is a product of mass and velocity. An example of momentum is this: in a collision between two cars, like let's suppose two cars are coming in opposite direction and they hits each other, the total momentum before and after the collision remains same. So if car 1 has a velocity of 20 meter per second and car 2 has a velocity of 20 meter per second and they collide with each other, so they must collide with a momentum of 40 meter per second, which is the sum of 20 plus 20 if no external force is supplied. Okay, so their momentum remains constant. So now let's move on towards the problems of this topic. These are the problems related to past FDE, EST Physics MCQs, and these MCQs are the most repeated MCQs in past papers. We are doing these. Okay. Which of the following statement best describes the law of conservation of energy? So energy cannot be created nor be destroyed. First is energy can create it but not, but this is wrong. Energy can destroy it but not, this is also wrong. And the total energy of an isolated system remains constant. Yes, we know that in law of conservation the total energy must be remains constant. So this one is correct. In an elastic collision, what is elastic collision? First of all, elastic collision is the collision in which your total energy is conserved. Okay, so in elastic collision, which of the following quantity is conserved? So in elastic collision, your both kinetic energy as well as your you can say the potential energy and you can say the momentum, everything is conserved. So the correct answer is C, both, because there is no option of potential. So the only answer is both kinetic energy and momentum is conserved in elastic collision, but in inelastic collision it is not conserved. Okay, if a ball of mass 2 kg moving at 3 meter per second collides, so the mass of the ball is given, which is 2 kg, and it moving with a velocity of 3 meter per second collide and sticks to a stationary ball of mass 1 kg. Because this ball hits with another ball with a mass of 1 kg with the velocity with what is the velocity of the combined mass after the collision. So you have to find the mass of the second. So how you can find? So the formula you use is momentum formula. Total momentum before collision must be equal to the total momentum after collision, means m1 v1 equals to m2 v2. So m1 is 2, v1 is 3, and m2 is 1 kg, and v2 we have to find, so we can easily calculate. So the answer should be 3 multiplied by 2, 2 3 2s are 6, and divide. So you will get the answer, and the answer should be 2 meter per second in this. Okay. So in this, what you have to do, the important thing is it says that you have to find the velocity of the combined mass after collision. So after collision, you have to use combined mass. So after collision, you have to use m1 plus m2 v. m1 plus m2 bracket multiplies by v. So how you can get? So because the formula we use m1 v1 equals to m2 v2. m1 is 2, v1 is 3, 3 2s are 6. So in uh, left hand side we have 6, and on right hand side we have m1 plus m2 multiplied by v2. m1 plus m2 becomes, so 2 plus 1 becomes 3 multiplied by v2, and other side we have 6, so 6 divided by 3 equals to v2, so you will get 2 meter per second. So the answer is 2 meter per second. Understood? Okay, so which form of energy is associated with an object's height about the ground? So if an object has some height, so it must definitely there is some potential energy. Okay, a car of mass 1000 kg is moving at a speed of 20 meter per second. What is the momentum? Now you have to find the momentum, and you know that the formula of momentum is P equals to mv. The mass is mentioned, which is 1000 kg, and the velocity is 20. So 1000 multiplied by 20 you will get the 20,000. So the answer is C, which is 20,000 kg meter per second. Okay, so this is the correct answer. Which of the following is true for the total mechanical energy is conservative system? So the total mechanical energy is conservative system. So which one is true? It's always decreased. No. It's always increased. No. It remains constant. Because our mechanical energy is conservative system. So conservative system means always constant. Okay, so it remains constant for conservative systems. For conservative systems, always there is a remains constant. Okay. Now move on towards next. If no external force acts on a system of particle, the total momentum of the system. If no external force on a system of particle, the total momentum of a system. If no means if no external force is applied, so what happens to the total momentum of that system? It should increase. No, because there is no external force. It should decrease. No, because no external force. If there is no external force, because means there is no change in the total momentum, means your total momentum remains constant. Okay, in a perfectly inelastic collision. Now, it inelastic collision means your conservation is not obey. What happens to the kinetic energy? It is completely conserved. No, because this is inelastic collision. It is partially conserved to other form of energy. It is increased. Never, 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 because energy can never be greater than the initial energy. So it should not be increased. It should remain same. It should not remain same because this is inelastic collision. So the correct answer is B. It is partly converted into the other form of energy. Okay, a pendulum at its height point has at its extreme point, as I told you before, it has its maximum potential energy. Okay, so the correct answer is the C, maximum potential energy. And at extreme position, its maximum potential energy and kinetic energy is zero. Okay, which principle basically explains when a rocket moves in the opposite direction of the expelled gas. Expelled gas is moving in downward and rocket is moving upward. This is according to the Newton third law of motion, and this is the conservation of momentum. Yes, not energy but the conservation of momentum. Okay, how conservation of energy? Because mass of rocket is going upward with some velocity, and mass of fuel which is exerting out, and velocity of the fuel which is in the opposite direction. So this is according to the conservation of momentum. So that's all for today. We will start our next chapter number 3 in our upcoming videos. We already did chapter number 1 in our first lecture of FDE EST Physics test, and this is our second video. We completed our second lecture of today, and we will start our third lecture tomorrow. And in tomorrow's lecture we will start our chapter number 3, which is about gravitations. In that we will discuss about the Newton's laws of gravitations and many more. Okay, so that's all for today's lecture. We did all chapter number 2 from starting to end. We discussed all the relevant topics, and we did the most repeated MCQs of past EST physics papers. Okay, if you did these MCQs, you are done with your 90%. Okay, so this is a complete. This is chapter number 2. We already did today. Okay, and this PDF is a combination of total 96 pages, and it is complete EST physics preparation MCQs, and these all MCQs are relevant to the most repeated past EST physics papers. By doing these problems, you got 90% of your results. So if you required these notes, so I can leave my WhatsApp number in the description below, along with our channel, where we update you about regarding tests, scholarships, as well as new updates. If you want these notes, you can contact me just leaving comment below or by contacting directly to my WhatsApp number. I will provide you these notes in a very little price. Okay, so that's all for today, lecture number 2 of EST Physics test. We will start our next lecture tomorrow. Till then, take care. Allah Hafiz.